Hi, I'm gonna explain how to solve a problem on Bernoulli's equation. And the problem says as this. The figure shows a stream of water in steady flow from a kitchen faucet. This is the kitchen faucet and this is the stream. At the faucet, the diameter of the stream, so here, it's equal to 0.960 centimeters. The stream fills a 125 centimeter cube container in 16.3 seconds. So our rate of flow will be equals to 125 centimeter cube per 16.3 seconds. Okay? We have to find the diameter of the stream 13 centimeters below the opening of the faucet. So if we take this position as our y2, that equals 0, our y1 will equal to 13 centimeters. And so for solving this problem, we have to find the diameter here, okay? Then we have to use our Bernoulli's equation. I'm gonna write it here. But first we have to calculate exactly the rate of flow, which is the rate of flow. So by doing this division, we have that the rate of flow is 7.67 centimeter cube over a second. Okay. Now that I have this, the rate of flow, I can use the equation of the rate of flow, and we know that the rate of flow is equal to the area times the velocity. So, for obtaining the area of the stream of the faucet of the upper part, we know that the area it's equal to P times the radio square, okay? And the radio square, it will be equal to the diameter, half of that diameter, okay? Then, as we see this, we can calculate the area of the diameter, of the area of the circle. And once we have the area of the circle, we can get that the velocity 1 would be equal to the rate of flow, that is 7.67 centimeter cube times second, and this will be over the area. That the area is pi, and here we have the diameter, it's this one, 0.96 centimeters over 2, and this square. Once we get the velocity 1, we will get that the value of the velocity 1 will be 10.6 centimeters over second. Then this means it's 0.106 meters over a second, okay? Once we know that velocity, we can go to our Bernoulli's equation that says that our pressure 1 plus rho, that is the density, times the gravity times y1, plus half of the density times the velocity 1 square will be equal to the pressure 2 plus the density times the gravity times g2 plus half density velocity 2 squared. Okay? Here we know that in the faucet the pressure would be the same one in this part that in this part. So we have one atmosphere as the pressure, and we can delete the pressures because they are the same one. Once we delete the pressure, we also can delete rho, that is the density, because it's in all the terms on the equation. And now we can substitute the gravity, 9.81 meters per second, per the G1, that our G1 will be 13 centimeters over the bottom of the faucet. So we'll have 13 centimeters as meters here. That plus this was the this part, and for the kinetic, this was the potential, and this is the kinetic. The kinetic would be half of our velocity 1, that we know that it's this one. So half of 0.106 meters over square. And this will be equal to half velocity 2 squared, and that's it. No, well, yes, because here our y2 was 0, so all this frame cancelled. So it's equal to only the kinetic energy, that is this one. Okay. As we take out the velocity 2 of the equation, we will obtain that the velocity 2, here the only thing we have to do is this 2, we pass it over here as a multiplying, and the 2 here that it's elevated, we create a square root, and the result of the velocity 2 will be 1.63 meters over second. Okay, so once we know the velocity 2, we can go back to the rate of flow, and we can write here that the rate of flow that was 7.67 centimeters squared over second will be equal to the area of the second part of the problem, and the area will be pi times the diameter 2 over 2, this is the radius square, times the B2 that we obtained here, that B2 it's equal to 1.63 meters over second. But we are using the rate of flow as centimeters, so we have to change that into centimeters. So we have 163 centimeters over second, and well, like this, okay? And then what we have to get out of the equation to take out, it's the diameter. So what we do here, we take out the diameter, and the diameter will be equal to the square root, because of this, of the rate of flow over, and these two get in this side dividing, so P times 163. And after taking this square here to make a square root, we only take these two out to get our diameter 2. And so we multiply this by 2. And this will get as a result 0.2447, that is more or less the same as 0.245 centimeters. So this is how you solve a problem with Bernoulli's equation to find the diameter.